Alright, now this time the question goes, a particle moves in a straight line. It passes through a fixed point O with velocity of v equals 2t squared minus 3t minus 3, where t is the time in seconds after the particle has left O. Find the acceleration of the particle when its velocity is 2 meters per second. First of all, we have to figure out the value of t when the object's velocity is 2 meters per second. So, substituting v equals to 2, we have 2 equals 2t squared minus 3t minus 3, which then becomes 2t squared minus 3t minus 5 equals 0. Simplifying and factorizing the quadratic function, we have 2t minus 5 times t plus 1 equals 0. We can then solve t equals to 5 over 2 or t equals to negative 1. Since negative values of time are invalid, we find that when the object is traveling at 2 meters per second, t equals to 5 over 2 seconds. Next, we need to differentiate v with respect to t as it represents acceleration. Differentiating v, 2t squared differentiates to become 4t, while negative 3t differentiates to become negative 3, and differential of constants are 0. So we have acceleration equals 4t minus 3. Now, all we have to do is just substitute the value of t equals to 5 over 2 into the function of 4t minus 3 to find the acceleration at that time. Finally, solving for a tells us that the acceleration at that time is 7 meters per second squared. Now let's use Casio ClassWiz to check your answer. Once we have substituted v as 2 into the function of velocity and simplified the equation as 2t squared minus 3t minus 5 equals 0, we can then use the equation mode of the calculator to solve this quadratic equation. First, press menu, then scroll down twice, press the negative sign button to select option A. Press 2 to select solving polynomial equation, and then press 2 again to select solving quadratic equation. Enter the values of 2 as the coefficient of x squared, negative 3 as the coefficient of x, and negative 5 as the constant. After keying in these values, pressing equal once gives you the first solution of t equals to 5 over 2. Pressing equal again gives you the second solution, which, as you already know, is invalid. To calculate the acceleration, press menu and 1 to return to the calculator mode. Press the shift button followed by the integration button, and this gives you the differential solver. Insert the function by pressing 2 alpha, close bracket, and the x squared button. Then, press negative 3 alpha, close bracket, followed by negative 5. Lastly, shift cursor to the right to enter the value of t, which is 5 over 2, and pressing equal tells you that the answer is 7. Now this answer corresponds to our earlier calculations.